some more advanced, very difficult topics, and showing how to do that here, so that hopefully this will teach people some good patterns for using RxQ. So this video series is going to be called RxQ Recipes Explained, where I'm going to walk through all of the recipes and hopefully give you guys proper explanations to help you understand them and leverage them yourselves. For this first session, though, I'm not going to jump right into the recipes. Instead, I want to give some setup for, what's the goal, what are the goals of this course and the prerequisites, and then talk about really the intro concepts. What is RxQ, how can you use it, etc. So to give you, let's start with RxQ itself. So essentially, RxQ is a JavaScript library. And really, all it does is it provides some functions that help you do reactive programming with the Click engine. So this library is all based around the Click engine API. So for those of you that are working in the Click API's world, but maybe haven't touched the engine API yet, it's really kind of the driver of how Click works, kind of the Click client. In fact, I'll pull up Click Cloud here and show you how today you can look and see how the engine API is working, even without doing your own development. So let me just log in here. So here's a Click Cloud Hub. I'm going to pull up an application that I have up there. It's called Iris. It has kind of the Iris statistical data set. It's a classic one in kind of data analytics demos and things like that. So it's got a simple data set with some kind of values about different types of flowers, the species, and like some attributes around the petal length, petal width, etc. So a very simple data model. Now this application is a ClickSense application, but under the hood it's communicating with the ClickSense engine to crunch the data and do all the calculations and filtering and things like that. All of that functionality happens through the engine API. So the ClickSense client uses the engine API to communicate with a ClickSense engine and make all this magic happen. And if you're using a tool like Chrome, you can actually see this happen with the developer tools. So you can pull up the developer tools in Google Chrome and go to the network tab and monitor the WebSocket panel. Now if I refresh the page with the WebSocket being monitored, what you're going to see here is I'm going to have a WebSocket that's opened. Let's go open an actual page. WebSocket that's open, there's a lot of them here. I'm going to try to find the right one. I think it's this one with engine data. No, it's not that one. Here we go. It's this last one here. What this does is it's established a session with ClickSense and it's running the engine API. And if you look through these different things, you can see what the engine API is doing, what we're asking it to do. So for example, when you open the application, the first thing it did was it asked the server to open the document. After that, you'll see other things. It's checking like, are we in personal mode? Get the app layout, create objects in the app. Objects have your calculations. Get the layouts from those objects. If I were to filter something here, let's just clear out the frames and click a species, for example, you'll see a bunch of API things happened. It began selections, it made a selection in the list box. Based on that selection, it had to update a bunch of my charts that were already in the page, etc. So this is really the engine API in practice. Now, to use this as a developer, you need some sort of library to do that, or you write one yourself, essentially, because really the engine API just works through this WebSocket, so you could write these kind of things by hand, but it would be very tedious, and eventually you would end up building something to help yourself do it. There are already a couple solutions to do that, one from Click called enigma.js, which I'll talk about later, and one from Access Group called RxQ. So RxQ really is a library for doing this, for helping you work with the engine API in JavaScript in a kind of scalable, maintainable way. And the way we do that is with reactive programming. So reactive programming is a very useful paradigm for building interactive applications. And really what reactive programming tries to do is create a declarative style where you declare how dynamic variables should change over time, and that kind of encapsulates your business logic or your application logic, and makes it much easier to maintain things like changing states and doing asynchronous calls and things like that. I've talked a bit about reactive programming in the past. The easiest example to understand it really is like looking at a non-reactive versus a reactive example. So a non-reactive example of coding, which is a very kind of imperative style, is to say something like A equals 1, B equals A plus 1, and A equals 2. In the non-reactive style, if you were to then print the value of A, you would get 2 because you said A was 2 last. If you print B, you would also get 2, because at the point in time when you called B, you said it was A plus 1, and A was 1, so 1 plus 1 is 2. So the variable didn't really change over time. Like, you didn't really define a dependency here. You were kind of doing a non-reactive assignment. In reactive programming, essentially values or variables are modeled as being dynamic and as being dependent on different logic. So when you say B equals A plus 1 in the reactive example, it sort of defines B as being linked to A. Like, B is always going to be whatever the latest value of A is plus 1. So in this case, with the same example, when I print A, I get 2. When I print B, I get 3, because it references the fact that A had changed and therefore updates itself. This is a really common pattern for people to use even outside of programming, because if you use something like a spreadsheet, like Microsoft Excel or a Google Sheet or something like that, then this same kind of concept is easy to code. You know, if you've done something like, hey, I have my value A and A is equal to 1, and I have a value B and B equals A plus 1, then those of you that know spreadsheets know that, like, this naturally changes. If I change this to 2, this becomes 3, 3, 4, 10, 11, etc. So really, like Excel and other spreadsheet solutions like Google Sheet are reactive programming interfaces. Now, there are libraries that have kind of ported reactive programming ideas to different languages, one of them being JavaScript. And so the kind of biggest that I kind of use library for this is RxJS. So if you look up, let's just look up RxJS, GitHub. RxJS is a popular reactive programming library for JavaScript, and essentially enables these kinds of reactive patterns. So what RxQ does is it really takes RxJS and creates functions around it that utilize RxJS to give you reactive programming with engine API calls. So when you do something like OpenDoc, like we saw in our ClickCloud example, that's an API call we can make from RxQ, and it'll use kind of reactive programming to bring us back the results asynchronously. So the reason we chose Rx, or why we like Rx for this, is that it scales up well for high, like, interactive applications with a lot of, like, complexity. And once you kind of learn how to read it and use it, the code becomes very easy to kind of modify and maintain. I'll give you an example away from Click. This is the Rx code for creating a drag and drop. I don't expect it, if you haven't done Rx before, there's no way you'll be able to read this, but I'll kind of, so don't feel like you should be keeping up with it, but I'll walk you through it line by line just to explain how kind of simple it ends up being. At the top, we just import the functions we want to use from RxJS, so we'll see those used later. In this example, in fact, this is a live example you can go play with. I have a box here, and if I click the box and drag it, it'll move around. So I can just drag this box and put it anywhere on the screen. So that's it. With RxJS, to build this kind of drag and drop behavior, this is like literally all the code. That's it. So I have a box, and the HTML looks like this. There's a box on the screen with some style applied to it. So very simple. And the way the code's written out is I have my box, so I just get the box from the DOM. And then I create a series of streams, which in RxJS is sometimes how we call dynamic variables. They're also referred to as observables, is really the real terminology. But to keep it simple here, we'll call it streams for now. I get 3 different streams from the page. I get a stream of mouse down events from the box. So anytime someone clicks down on the box, I'll get an event fired. I create a mouse up event stream from the document. So anytime someone releases the mouse, I'll get a value in my stream, and I have a movement. So whenever I move the mouse, I get that value. So these 3 different streams. The cool thing about reactive programming is that you can combine the streams to make new streams. So if I think logically about what I want this drag and drop to do, what I want is when someone clicks on this, while they're still clicking down, if they move, this thing should move. If they let go, if the mouse goes back up, then it should stop moving. So if I can describe that kind of logic, then I can create it in RxJS. I have kind of all of the components for that. I have the mouse down event that initiates my drag. I have the mouse move event that happens while I'm dragging, and I have the mouse up event that ends my dragging. So this is the part where you will definitely be tough to keep up with if you haven't done Rx before, so don't worry about the syntax. But essentially what this syntax for my move stream is saying is take a mouse down event, and whenever that happens, start listening on mouse move events, and do that until the mouse up event happens. So that creates this action of mouse down starts a stream, starts like a new set of values for mouse move. So as I mouse move, it happens. And then when I let go of mouse up, it stops. Now I can use that stream. I have that event happening, and I can just use that to move the box. So I subscribe to that movement stream that I created, and I basically take the box and I move it based on what's happening with that mouse move event. So it's really that simple. What's cool about this is that then you can scale this kind of concept up to doing things like in Click, working with an asynchronous data source. So Click Sense, or the Click engine, lives on a server. So you have to make asynchronous API calls to it, right? You have to make network requests and wait for the responses over time. And the Click model itself is actually a very kind of reactive entity if you think about it. So if you think about what a Click model does, is it has like sort of a state of data in memory, and then as you make API calls against it to do things like filter or search or create new objects or change variable values, it modifies that state. So you kind of have this changing state over time. So it's really a reactive engine. It reacts to user input and produces new states of data based on those API calls or user inputs. So we find that Rx then pairs very well with Click in this model. I mean, it's kind of designed for use cases like that, and they kind of go hand in hand. Now, I mentioned before talking about Enigma, and really what I wanted to do is highlight the differences. So if you're curious, like, why would you use one versus the other? What are the different strengths, etc.? You can hopefully this will help. Enigma.js is an awesome library, formerly known as QSOX. It's what got me started using the Click Engine API, and it does a great job of helping you work with the Click associative engine in JavaScript. Once again, in a scalable way, just like RxQ. Really, the difference between RxQ and Enigma can be boiled down to the underlying technologies. So Enigma uses something called promises, and promises are a certain way of working with asynchronous data in JavaScript. And RxQ uses observables, and with observables, that's where you get the kind of reactive programming paradigm, whereas with promises, you're not really getting that reactive programming type of approach. So they're different approaches. As part of these talks, by the way, I want to focus kind of on RxQ and usage. I'm not going to go deep on concepts like around reactive programming and things like that, but what I will do is provide resources. So I will point you to links and URLs as much as possible to say, if you're new to RxJS or reactive programming and you want to learn more about them, you should go here. So we'll come back to that. Let's talk about this Enigma thing, and then we'll come back to how do you learn a little bit more about Rx if you haven't used it before. But essentially, going back to Enigma versus RxQ, you have Enigma using promises. And so promises, they run once and then kind of provide a single value back. They're standard async method in JavaScript. They're widely kind of supported now. So it's a great place to start. I mean, you can build really complicated applications using them fairly easily. It's a great library. Really, RxQ has a harder learning curve because reactive programming and the observable pattern are newer in the kind of JavaScript world, aren't as widely adopted. So it's a new kind of way of thinking and approach. So I'll say you get a bigger learning curve with it. And even doing some of the basic stuff, you could probably do with kind of more not efficiently, but basically like less code or easier to kind of figure out in Enigma than you can with RxQ up front. So it's probably got a little more of a burden in terms of like learning how to use it. But once you learn how to use it and you go to advanced use cases, I think it scales up fantastically with like really kind of advanced, complex interactions you want to have with the engine. It's allowed us to build some very complicated applications in some very, very simple ways. So really the difference is if you want to take advantage of reactive programming and all it has to offer with working with interactive applications and developing on asynchronous data sources, then RxQ is kind of meeting that demand. But again, Enigma is a great place to do this kind of work, and the promise model can accomplish similar things. So hopefully through some of the recipes, you'll kind of see where RxQ starts to shine as we get to the lower part of the list and get to the more complex examples. You'll see how reactive programming can solve some pretty difficult problems in some pretty straightforward and easy to understand ways. I'd mentioned that I was going to provide resources as we went along, and I kind of breezed through why Rx without giving you resources for looking at Rx. If you go to this page, there should be some links. There are. This is good. Check these links out. The best one that I've seen that really got me started on reactive programming is this guide by Andre Staltz. the introduction to reactive programming you've been missing. It's a great example because it explains the concepts of reactive programming in a very easy to understand way without getting you too bogged down in the terminology, which can be overwhelming up front. And it walks you through a kind of an example, like an example you can code along with. And so for me, reading this and then coding the example really helped me understand like what the value was, especially the example, and kind of coding it out and seeing how it could be done. So he, in this post, he shows you how to build essentially a kind of copy of Twitter's who to follow UI element that has like a refresh button to get more data from a server and things like that. So this is a great place to start if you're new to Rx. Again, during the course here, I'll try to call out things that are kind of Rx specific and topics you should read up more on if you're not familiar. But I'm not going to try to explain them as we learn the RxQ concepts. I'm just going to highlight them essentially. If you want an even quicker read than that, I've written something. It's on Medium, and it was part of the ClickBranch publication, which you should subscribe to if you're not, because there's a lot of great posts on there related to the APIs. So with this this post kind of talks through at a very high level some of the things we've already covered here around like non-reactive versus reactive, the Excel thing, but goes into some more concepts around how you can visualize Rx for yourself, kind of reactive programming, and think about it, and introduces terminology, which we're going to be using a lot of in this course, talking about what an observable is versus an operator versus an observer and a subscriber. So if you don't know these terms, this might be a good place to start, and then maybe reading some of the RxJS documentation. So with that being said, let's jump into core concepts of RxQ. So in RxJS and other reactive programming implementations, the key driver of the reactive behavior is this object called an observable. An observable is essentially, it's like a function that returns values over time, so it can deliver values to something downstream. So you can use it to model changing values. Like let's say you could model your age as an observable. So you might be, 40 years old, and that's your current age. But in a year that changes. So that observable would keep track of the fact that your age changed, and it would deliver that new value to anyone that was like listening for your age. So let's say you had some sort of like fitness app or something on your phone, and it lists, attributes about yourself, including your birthday and your age. And so it's listening on that observable of your age. And when your age updates, then that gets that new value and prints it out, right? So it's a value that changes over time. And observables model that. So the idea with RxQ is that it models Click Associative Engine API calls with observables, because those values will either change over time or be delivered over time. So if I make an API call to open a document, for example, I'm going to have to make that call and wait for a few things. I'm going to wait for the network, for the message to go from my computer to that engine to initiate the request. Then I'm going to wait for that application to get opened up into memory. So Click can spend some time doing that, getting it all loaded. Then I'm going to wait for the response to come back to the client from the server saying, hey, the application is open. Now you can interact with it. So the observable is going to wrap all that with that time delay and kind of deliver that value later. So we can kind of expect to get it later from the observable. And that's essentially what RxQ does. Like really at a low level, that's the biggest component, is kind of giving you the ability to use reactive programming through observables with the Click API calls. There are other things that it does behind the scenes, and to understand those, we need a little bit of kind of Click Associative Engine background. So I'll give you a little bit of that here. We saw a little bit of this already, but essentially the way the Click Associative Engine works is it uses a WebSocket, and it uses JSON 2.0 RPC or RPC 2.0 to convey its messages. So you send it a message with this format that looks like, what's my method to apply, what parameters do I have for that method, what ID is this request, and a couple of parameters that are unique to the Click implementation, the Engine API implementation. And then you get a response back. So this was response 44, or request 44, and here's like response 44 that tells me some useful information that I might need to update my interface. This will come later, what exactly this means, but essentially you can map requests to responses this way. So in fact, if we refresh the page and go back to that open document call, Let's just see that happen. And with this, you can figure out the timings of the calls too. So if you want to know how long did this take to really execute. So here's open doc. It was the first kind of request we made, ID number 1. And if we get the result here, result number 1, and here's the result that says, hey, you have a document, and here's like the generic ID that Click has for the document. So you can reference this ID to get back to the document. And here's the handle for the document. Handle is an important concept we'll come back to. So we're going to wrap this in an observable and be able to get this delay later. As you can see, this took about 110 milliseconds or 120 milliseconds to execute. So we're going to get that 120 milliseconds later, and then we can operate with it. So that's going to be useful for not only knowing when to work with it, well, really that's the main use case, is knowing when to work with it, right? So if I want to do things like make calculations, make selections, etc., I have to make sure that I have this application open first before I can do that. So with observables and also promises, we can chain these things together that way. So using RxQ to make API calls then becomes pretty straightforward. I mentioned the concept of the handle. We should talk about that, so let me go back here. When you see this document come back, you see it gives you back this concept of the Q handle, and the Q handle is 1. Essentially what a handle is an instance of an entity in your ClickSense engine. So if you look at the Click documentation, go to the developer docs, and you look at the engine API, what you'll see is a bunch of classes. So you have a global class, which represents the engine itself with functions related to the engine, such as let me create an application, or let me get a document, or get a document list rather. Then you have like an app class, for example, that represents an application that is open. And the app class has methods like apply a bookmark, clear all your selections, create an object, evaluate an expression. Right? So these are all methods that happen there. So these classes are basically like types of entities that you can interact with in the ClickSense server, or the Kix engine rather. So the handle that you get back from the engine, the handle is an instance of these classes. So when I got back the handle is 1 here, what that's telling me is, okay, there's a document open in my session here, and the handle identifier for it is number 1. So if I want to make calls against that app class, this instance of the app class, for this open document, like I want to clear all selections, I want to do it for the entity that has Q handle number 1. So the handle is basically telling Click, like the engine, what object am I talking about running this method with? So in this case, you look for any calls you see related to the app, like get app layout, you'll see that we run that on handle 1. Or creating objects, we're doing that on handle 1. However, OpenDoc happened on handle -1. So -1 is the default handle for your engine session, for the global class for your engine session. So it's a very important concept. You need handles to make API calls because you have to tell Click where to apply the API call. So going back to this documentation, here's the very, very quick and dirty how to use RxQ to make an API call. Very simple. You import the API call you want from the API. So I have this RxQ/global. All of the API endpoints in RxQ are namespaced this way based on the Click class. So you saw in the documentation app class, global class, field class, etc. That's where you'd import it from. So I want to import a global class function. If I go to the global class list, there's a function called engine version. And what engine version does, it doesn't take any parameters. You just call it against a global class handle, and it gives you back what's the version of this engine that you're looking at. So what I can do here is import engine version, that function, from RxQ/global, because it belongs to the global class. And then I can create an observable for the version based by calling engine version on a handle. So this function says, give me a handle, and I will execute the engine version API call against it. That's basically it. You'll see in a lot of our code we put $signs at the end of observables. That is not a syntax necessary thing by any means. That's just kind of a naming convention that helps us at Access Group at least to keep track of when we're working with an observable. So version $is an observable because that's going to be an API call that executes over the network. It's going to take time to evaluate and come back. And if I want to use it, I can just subscribe to that and say, when the version comes down, maybe I'll console it out, log into the console saying the version of the engine is this item. That's a very simple example. You can add parameters to this. So certain API calls will have parameters, such as OpenDoc. For OpenDoc, you're going to also call that against the global handle, but you need to give it the document name or ID to open. So if I wanted to open a sales.qvf file, I could import the OpenDoc function from RxQ/global, and I could say OpenDoc against my global handle, open the sales document. And this is going to be an observable for the app handle, essentially. So this is really all RxQ is. It's not, at a base level, it's not that complicated. If you know how to use RxJS, then this becomes very easy to do. I think the barrier for a lot of people will be kind of getting their hands dirty with reactive programming, and I hope these examples show you how to do that and why it's valuable. Now, if you're paying attention, you may be wondering yourself, okay, but how do I get the handle? Like, what's going on there? So we're going to cover that when we go through the basics, which are going to give a lot more details on how RxQ kind of really works and is structured. So starting with the basics is really connecting. If we want to use the click associative engine, we have to establish a session with it, right? The session that's really happening over the WebSocket, like you saw with the Click Cloud application that I was looking at. So RxQ provides a function for this. It's called connect session. And this function, you call it with some configuration to tell it where you want it to make the session. You know, what engine or server is it on, what port. Do you want to use open it for a specific application or a specific session ID, etc. And it'll set up that session for you. This is also an asynchronous event to set up a WebSocket and wait for it to open and make sure you're authenticated and things like that. That's going to take time. So we use an observable for this as well. And what will happen here is when the session is properly established, that observable will return the global handle. So that's how you get the global handle that I mentioned before. It's an asynchronous request. You have to get connected to the server so that you can make API calls against that server. So the setup for Connect Session, there's a bunch of properties you can read through here, but to get started with something basic like using ClickSense Desktop, if you have ClickSense Desktop running, then you're able to kind of access ClickSense this way. So running ClickSense Desktop in the background, you could run some code where you import the Connect Session function from RxQ/Connect, and then you call Connect Session and define some properties. In this case, I want to hit the local host, which is where the ClickSense Desktop is hosted. I want to use port 4848. That's what ClickSense Desktop uses as its port. And I don't want to use SSL, so I'll say it's not a secure connection. So I've called this a sesh dollar variable, standing for session, because it's going to be an observable that establishes the session and returns us the global handle. And you can see down here I've just put some code saying, okay, subscribe to this, and when this is done executing, we'll have the global handle. It'll be accessed. So that's it. That's how you set up a session, essentially. So once we have that, then we can make API calls. We saw an example of that before, but we skipped a step. We kind of assumed we had a handle, but then I brought up that question, right? Well, how do we get the handle? We have to get the handle asynchronously. So this section really will cover how do we use Rx to asynchronously get the handle and then asynchronously make API calls on it. So we're really kind of like chaining asynchronous events together. It's like establish the session with the server and get the global handle back. Now that I have that, then use that to call engine version and get the engine version back. So you can think of it as like taking these leaps of asynchronous behavior. So the way we do that, in Click, in the engine API, as you saw, certain API calls will give you back references to handles. Like OpenDoc gives you back a reference, as we saw, to a doc handle. So it says it has a type of doc, and it gives you a handle number that you can reference. The same thing happens with other types of entities. Like if you're creating objects, like a session object, you'll see the return for this. This is ID 12, so here's the response. You'll see it also returns a handle, and it's handle 4 for that specific object. In this case, it looks like it's like a list of app properties or something. So RxQ will watch the responses coming back from the session you've established, and it will create kind of instances of a handle for you in the RxQ kind of world. So RxQ has its own handle class that's meant to represent the class that's in the instances that are in the server. So going back here, when I call something like OpenDoc, I'll get back an app handle. If I call getField, I will get back a field handle, and RxQ knows how to use that handle to make an API call around it. So that part's pretty simple. So if I think about getting the engine version then, what I really need to do is leverage higher order observables. So a lot of people find Rx a little bit tricky up front, and then they get the gist of it, the basics of it, and they get moving. But then sometimes they get to the next hard part, the next kind of peak, if you will, and that is higher order observables, which are like observables of observables. Very, very useful concept. I encourage you to read on these and really learn them because they're so powerful, and you can't really use RxQ without understanding them. So you kind of are, if you want to go this route, you're stuck kind of learning them. The best resource I've seen for this is this Egghead course. Unfortunately, it's not free. I looked for free resources around this stuff. I could not find any really good ones, but this video series is amazing for explaining this concept. I thought I understood the concept well, then I watched this course, and it really had a big influence on how we ended up getting to RxQ 1.0. So can't say enough good things about this course. You can also always try reading the documentation, but the documentation is a little bit, it's documentation. It's not meant to be a kind of tutorial by any means, so it probably won't make that much sense to you. So going back here, essentially there are various operators that allow us to work with higher order observables, such as merge map, concat map, and switch map. In RxQ, we end up using switch map a lot. So what switch map does is it says, like, use the latest value that's come in to create another observable kind of asynchronous set of values and put that into my stream. So that looks like in practice down here is that when I establish this session, as you saw before, my session returns a global handle in it. So what I can do is I can use switch map to say, okay, when that session delivers a global handle, I want you to take that global handle and I want you to figure out the engine version from it and then flatten that back out. So this is how we chain these asynchronous events together with switch map in this case. So session establishes the session, delivers the global handle. With the global handle, we say, okay, convert that to an engine version using our engine version function. Run it with that handle. And then we can kind of log out the version. So you'll see H referenced a lot in our switch map statements as handle. That's just H for handle. It's kind of a convention we use. You could use the full word handle. For some examples where we're doing multiple steps with different handles and different types, sometimes we name the variables based on type, like this is my app handle versus my object handle versus my global handle. But in general, you'll see a lot of kind of H being thrown around, and that's just referencing a handle instance in RxQ. So this is how you make that API call. Once again, connect the session, take the session and calculate engine version against it, and then use the engine version somehow. And so you can keep going down the sequence. Like instead of doing engine version here, I could have done open doc, and that would have then given me a handle for the doc. And then I could have said switch map from the document handle and turn that into the app properties or something like that, because I want to get the metadata about the application. And you'll see that when we jump into the recipes in the next video, we'll walk through those examples and you'll start to get a feel for how that works. One really important concept in RxQ development is reusing handles. So if you're new to reactive programming, one thing that is not obvious, or at least it wasn't obvious, and it wasn't obvious to me up front, is this idea of observables being cold. And what we mean by cold is that observables don't act until they have an observer, and they act for each observer separately. So another way to think about that is an observable is producing values, right, over time. So you might create an observable of just numbers. In fact, we can just let's code this up real quick. It's not that hard to do an example. Maybe we'll do JS bin so I can add Rx on the page. So I've got RxJS loaded on this page. We'll pull up the console. RxJS has its own kind of internal functions for creating observables, some that could be very useful, like an interval. So I can do something like create an observable of intervals. That'll be rx.observable.interval 1000. And I'm going to add an operator to say take just 5 of these. Now if I subscribe to this stream, what you're going to see interval does is it'll produce a number every 1 second. So I run it. You provided 5 where a stream was inspected. Sorry, take, not take until. Let's try that again. So there's the value 0, 1 second later 1, second later 2, 3, 4. Right? So this is a classic observable kind of demonstration. It's producing values over time. RxQ works the same way. You make an API call and you wait some amount of time, hopefully usually milliseconds, and then you get back something from the engine. So same kind of concept, producing values over time. Now, a key thing to point out about observables, though, is that they don't execute if you're not subscribing to them. And they also execute for each subscriber. So they'll produce new values for anybody that's listening. So let's say this is kind of observable 1. Let's add a function here and say, or we'll call this subscriber 1, and then we'll console out the value. But let's add a second subscriber based on a timeout. So let's add what we call a late subscriber. And we'll add it 1,000 seconds later. And so we'll say, this is a totally new subscriber. Clear this, and we'll run it, and we'll see what happens. So sub 1 is firing, 0, 1, 2, but then you'll see sub 2 starts firing. But you'll see sub 2 is not getting the same values that sub 1 is. It essentially kind of like started over. So you see when sub 1 was like between 1 and 2, subscriber 2 was already like printing out 0. It was like starting over with its own stream of values. This is the idea, is that observables are cold. They only produce values when someone's listening, and they produce new values for every listener. Now, that works well for like a lot of reactive use cases. This is a really useful feature of the language. However, there are certain cases where we don't want that, where we really want to share a stream of information. And the engine API with Click is one of those cases. We don't want every subscriber that wants to use the doc handle to go and open the document again. We don't want every subscriber that's going to use the session to create a new session each time, right? We want that to be shared. So we can do that in RxJS using multicast operators. And by the way, for more on this topic, this article is very good. This article, Hot vs. Cold Observables, by Ben Lesh, who's the RxJS 5 Plus lead, and explains the concept, and also explains, I think, how you create observables that share their values with their subscribers, which is called multicasting. There's a lot of different ways to do that. Again, I won't get into those. You can kind of research yourselves. But one way that we find very useful to do that is with an operator that comes with RxJS called share replay. So what share replay does is it basically shares the last value with any subscriber that joins. So when you connect a session, if you're the first person to connect to that session, to subscribe to this guy, then it will create that session for you initially. But from then on out, any other late subscribers that come are just going to get that like latest value. It's not going to try to like add another connection for this new subscriber. So in RxJS, we call that being kind of hot, kind of a hot observable versus a cold observable. Now in RxQ, we want to reuse the handles. So we want to get the handle once for a session, for a document, for an object, and then we want to make probably multiple API calls against that. So you'll see a very common pattern in RxQ development is whenever you create an observable that returns a handle, you almost always want to share that handle so that anyone that's using it is using the same handle. So when you rewrite something like this, maybe we want to write some code that says like, let's calculate the engine version and let's get the document list from the global class. So we're going to run 2 global methods against the session. We want them to be against the same session. So when I create my connect session here, I share the replay. I say just share the latest one, hence the 1. And that means that every subscriber will be listening and getting the same handle. So when I call version here, it's using just the one session I created to calculate the version. And when I subscribe to get a document list here, there's a typo. This should say get doc list. I need to update that. But assuming this code is right, when you write that, it will get a doc list all from the same session. So again, this is multicasting the handle, so everyone is reusing the same handle. Very important to make sure you're doing this properly and check your WebSocket traffic if you're not sure, to make sure you're not producing multiple handles, because otherwise you could write some code that quickly overloads the engines with requests and responses because you're not sharing the things you wanted to share across subscribers. There are some other useful topics in this section around kind of invalidations in the engine, and this is really more stuff around how Click works more than anything else. If you really want to go deep on this, rather than like listening to me talk over a body of text, there is a tutorial on playground.click.com that was actually created by my team at Axis Group. So I'm very happy with the work the team did on producing this. It's a engine tutorial, so you find it on playground.click.com, go to learn, go to engine tutorial, and it walks you through the engine and how it works. The first kind of 4 chapters are just like does the engine work at a low level, and even gets you typing like basic JavaScript, like vanilla JavaScript to work with the engine. And then the rest of it walks you through Enigma, since that is the Click supported solution. We kind of show you how to use Enigma, and so if you're interested in that, that's a great place to learn. But if you are on this RxQ path with me here, but you want to learn a little bit more about the engine, going through these first 4 will definitely help you. And one section that's particularly helpful is the staying in sync with the engine, which talks about the concept of invalidation and kind of object life cycles. So essentially, if you think about your handles on a server, you're usually getting data from them. So let's think about the app properties, for example. Like I get an application, I use OpenDoc, and I have a handle for the app class. And maybe I call get app properties on that. And that gives me back some metadata, and one piece of metadata it will give me is like the last reload time, or the last save, let's use save time, the last save time. Okay, great. That's a property saved on there. Now, if someone were to, maybe you're using the session and you click save after you've already gotten that app property, the app properties are going to update. So on the server, the save time is going to change. But on your browser where you got the app change time, you don't have that save time. You have the save time you got when you first opened the document and asked for the properties. You don't have this latest one. So now you have this disconnect where on the server the save time is one value, the real value, and on the client you have an old outdated value. So the question becomes, okay, how do I stay in sync with the server? Because again, the Click engine is a reactive engine. It has kind of a state to it. It has all these properties in the server that change while you're interacting with the session. So how do I make sure that what I have in the client is in sync with what's actually happening in the server in my session? So what Click does is they provide what are called handles, invalidation events for your different handles. What an invalidation event means or kind of represents is when something changes on the server that affects the properties of your handle, it will shoot you a message saying, hey, that handle that you had gotten some info for, that's now invalid. You are no longer in sync with the engine. So we can visualize that here. Let's take, for example, a calculation I've done in Click, sum of sales in the engine. So the app had 4 records in it. I calculated the sales. I got that down. I'm in a valid state. And the engine knows that because it knows I called this function to get that value. Great. What happens if I filter the data model? If I click filter, I filter to 1 record, I'm invalidated now. Because I still, on my side, I have that sum of sales is 232. But the sum of sales 232 was really what it was for 4 records, not for 1 record. So this number that I'm maybe displaying on my dashboard or something is no longer in sync with what's actually happening in the ClickSense engine, like in my data model. So I need to respond to that and say, let me get the properties or get the layout again to come back in sync. When you do that, Click recognizes, okay, you're validated again. You've revalidated to that object. You see the number updated to 50, essentially. And I can reset this back to 232. So that's the idea behind invalidation. Click tells us, hey, this changed. Do you want to respond or not? It does not automatically send you updates, which is good because it gives you flexibility to handle those updates differently. It just lets you know, hey, maybe you should update if you want to. This would be a good time to do it. And you can determine from there, okay, do I really want to keep this thing in sync, or am I going to wait and do this later, or do I not care about this object anymore and I'm just going to drop it and not worry about it anymore? So handle invalidations are really important. RxQ provides a way to get to them through a special stream on handles called the invalidated stream. So when you have a handle, like from an object or a global or a document or whatever, on that handle, that H variable we've been looking at, there is a property called invalidated dollar. And what invalidated dollar does is it will provide back for you a stream that lets you know every time Click tells you, hey, this thing invalidated. So that's useful because then we can write logic like this here, which says like, hey, every time it invalidates, I want to get the layout or get the properties so that I'm validating it again, and I'm making sure that I'm showing the latest data. So we can use that invalidation stream as a trigger for ourselves to make updating calls to get the latest data and update our front end appropriately, or whatever solution. RxQ works in Node. You can use it for backend stuff as well, which we've done in the past. So it's an important concept. One last one, suspending invalidations. This is not as important from a beginner standpoint. It really comes into play later. So in fact, let's just not worry about it for today. It's probably a little bit too much. So again, I want to reiterate the purpose of today's session, and that is to kind of introduce you to RxQ, kind of understanding what it's supposed to do and understanding what you kind of need to know or can learn along the way to keep up and leverage it. Again, it's really just about reactive programming. How do I do reactive programming with the Click APIs? RxQ bridges that gap. It allows you to use RxJS concepts and functions with Click API calls. In future sessions, I'm going to dive into the recipes, and that's where we're going to get into a much more granular level about line by line, how do we code this, how is the code working, etc. If you have questions about what we're talking about or need follow-up, like, hey, you talked about the multicast operators, and I can't really find a good resource, or I'm struggling to understand it, just let me know. Ping me on Twitter or the Click branch Slack, and I will try to find some better resources and share those so that I can help you learn these things. That took me some time to learn myself. So thanks for joining. The next one will probably be sometime next week where we'll start to actually go through recipes. And we'll be doing it in a live coding way. If you haven't looked here, these examples are live online. You can click the sandbox and see this example being kind of leveraged. And you can even click the edit button and fork them and play with them yourself. So we're really trying to make it easier for you to get hands-on with RxQ. So if you want to jump ahead, feel free to go and play with some of these examples and change some things and see what you can do. Hope this helps, and thanks again for watching.